Okay, guys, in this video, we will also look at how to integrate over a polar region. All right, so we're going to switch and also integrate. Now, this is going to be a little bit of a more difficult integration. However, you need to be ready for it because a lot of times I put these things on my tests. So do not tell me that I did not warn you here. Okay, so this dA business just means either dy dx or dx dy, depending on the situation. And they just like to put dA when it doesn't matter. All right, so what we want to do is switch to polar. How do we do that? Well, first we have to set up the limits. And the way we set up the limits is with first we want to fix theta. So fix the angle with the x-axis, right? And it's going to start over here somewhere, right? At 0, that would be the distance to the origin. And then when we are on the circle, we're going to go all the way till the radius of the circle. Looks like the radius is 4, right? So your r is going to go from 0 to 4. And then theta would be, from over here to over here. That's theta. But like this is 45-degree line, but it's in the second quadrant. I think that would be 3 pi over 4. And then you add another pi over 2 to that, like 90 degrees. And that would be like 3/4 plus 1/2, or 2/4. That would be 5/4. So this should be 5 pi over 4 on theta. So just also be careful with the order of integration, because these limits right here, those are supposed to be the r limits. And then these limits should be the theta limits. So don't mix them up. So the theta should be outside. So that should be 3 pi over 4 to 5 pi over 4. And the radius looks like it's 0 to 4. So remember that I assume that r is positive. So let's just check that. And then let's go ahead and see if we can switch to polar in our integrand. So we're integrating 2 divided by square root 16 minus x squared minus y squared. So you should know that in polar coordinates, x squared plus y squared equals r squared. So how can you simplify this expression? How can you convert that to polar? Well, if you take out the negative, then you're going to get x squared plus y squared. So y plus, remember the negative will get distributed and that will result in these two minuses. So this thing will just become 16 minus r squared, right? So you get 2 divided by square root of 16 minus r squared. Now, one thing that I want to also point out is that there is no way to further simplify this expression. So unfortunately, if you're not careful, you can make a mistake and think that that's just 4 minus r. Like, can't I just take the square root of 16 and subtract square root of r squared, which is this r? Well, the answer is no, you cannot do that. And that doesn't work. You cannot break the square root over a minus sign. You can do it over a times or division, but not over plus or minus. And if you ever want to do something crazy like this, just plug some r value and see if the two sides are the same. Just don't use 0, because at 0 is actually the only time when it does work. But for example, when r equals 1, if I were to substitute it, I would get 16 minus 1 squared. Well, that's just 15, square root of 15. But is that equal to 4 minus 1, which is 3? No, it's not. So hopefully you do understand that something like that is not okay. Now, I did forget something. So here we got dr d theta, and here we're going to go from 3 pi over 4, 5 pi over 4, and 0 to 4. I did forget something, and that is something is the pirate. Remember, the pirate says R. So the pirate is this what's called the Jacobian, which is when you switch from one set of coordinates to another, you get this term that seemingly comes out of nowhere, but it's not really nowhere. It comes out of switching to different set of coordinates, okay? So this is something we have to integrate. How are we going to do that? Now, one thing that you should realize that this is a splittable integral. By splittable, I mean that this integrand can be written as a product of something that has r multiplied by something that has theta. Well, you would be saying, well, what is the something that has theta? Because theta is not there. Well, okay, well, just multiply it by 1, and there you go. So you can then because also the limits must be numbers. So the limits had variables, you wouldn't be able to split it, but they don't. So this is just 1 d theta multiplied by 2r divided by square root of 16 minus r squared dr. All right, so by the way, this is an improper integral. So you do have like when you plug in 4 on the bottom, you get a 0 on the bottom, but improper integrals sometimes converge. So that does not mean it does not exist. You can actually evaluate it. The first one will be very simple. So that will just be theta. And we substitute 3 pi over 4 to 5 pi over 4, which when you just subtract them will give you pi over 2, right? 5/4 minus 3/4 is 2/4 over 1/2. So that part is going to be pi over 2, but you have to evaluate this other integral. And that one we're going to do by substitution. So 2r, so be very careful. You need to know how to perform the substitution like this. So the way you do that is you make the expression under the root your u. So you're going to say, okay, let u be 16 minus r squared. Then you're going to say that du, which is differential, equal to derivative of this thing with respect to r. Well, derivative of 16 is 0. This will be negative 2r dr, right? So now you can solve this for dr by dividing both sides by negative 2r. So this is going to cancel that here. All right, so let's start substituting. So I'm going to have 2r. The bottom becomes square root of u because I just renamed 16 minus r squared into u. And then I will have this dr, which is du divided by negative 2r. And here, this extra r that comes from the pirate is going to come in handy because we're now going to be able to just cancel that, but the negative will stay. So this is negative 1 over square root of u du. Now, how do we integrate something like that? So you need to know that whenever you have square root of u, that is the same as u to the power 1/2. But because it's on the bottom, when you have something like this, so this is u to the power 1/2 that's on the bottom, you can move this to the top. And when you move it, it becomes negative power, right? So you're going to have u to the negative 1/2 over 1, or just u to the negative 1/2. So you are integrating u to the negative 1/2, really, which means that you're going to add 1 to that. That'll give you u to the positive 1/2. And then you are dividing by the same thing, which is 1/2, right? And I'm done integrating. That's it. And then dividing by 1/2 is the same as multiplying by 2. So this integral right here will become negative because there was a minus right here. And then it'll be 2 square root of u. However, because this is a definite integral, and also you cannot just leave u in there, I always go back to the original variable. So there are some people that when they do substitution, they change the limits. I don't like that. I'm just going to go back to r and substitute the old limits. And you should get exactly the same answer either way. It doesn't matter to me how you do it, as long as it's right. And then you just substitute 0, 4. Okay, so substituting 4 first gives us 0 minus, now let's substitute 0. That'll give us negative 2 square root of 16. Well, square root of 16 is 4, so this will just be 2 times 4, or 8. So we got 8 from this second integral, but we also had a pi over 2 from the first one. So when we multiply them, that should give us 4 pi, which would be like the final answer. And this was kind of painful there.